So Mark, I understand you're the manager of the distributors, which Digi-Key is one of our distributors. And we've just come back from a show where they were presenting a program. And what can you tell me about Digi-Key?
They're an authorized distributor of ours. They stock a lot of different parts, including our C4A and C5K pre-wired gauges, so very easy to use. All the surface prep kits, all the materials that you need in order to bond the gauges correctly.
Good. And today, that you mentioned that C5K gauge, we're going to demonstrate bonding this particular gauge to what would be the equivalent of a printed circuit material. That's their ruler that they send out for shows. But that way we're going to show how to demonstrate how to put it on what is equivalent to an FR4 material. And Hugo Martinez is going to be the one who's going to be helping us with that. So first thing we got to do is we need to degrease the surface. So Hugo's going to take the CSM3, having already tested on a corner to make sure it doesn't melt the circuit board. He's going to take the CSM3, spray it into a gauze sponge so it doesn't evaporate too quickly. And we're going to degrease the surface where we're going to bond the gauge. We're going to be bonding the gauge right here in this area right next to their logo. So we did the degrease. The next step is going to be a dry abrade with the 320 grit silicon carbide abrasive paper, SCP-2. Closer over here so we get that. We're going to put it in that square. There you go. That should be sufficient.
All right.
Oh, we'll get down into the copper. Maybe we need to go down into the copper. Let's go down to the trace there.
All right.
Because I didn't realize that was just paint. There we go. That should be good enough, and then we'll do the wet abrade with the 320 and that'll finish the job. He's going to take the conditioner A, the mild phosphoric acid solution, red tip bottle, and he's going to flood the surface of the circuit board, and then he's going to wet abrade with the 320 grit silicon carbide abrasive paper. Conditioner A is a mild phosphoric acid solution which helps to remove any oxidization from the surface and any organic components that might need to be getting rid of. That should be good enough. Now he's going to take a clean, dry gauze sponge, fold it into quarters, and with a single wiping motion, he's going to absorb the contaminated material off of the circuit board. The next step will be to wet abrade with the 400 grit. We want to get to a surface finish of nominally around 60 RMS for the proper bonding. And the 400 grit on this copper material is probably going to come out to be just about that.
Tom, what would happen if you didn't remove the paint?
Well, do you want to know the strain in the paint, or do you want to know the strain in the circuit board? Most likely, and I can almost guarantee the answer, you're going to want to know the strain in the circuit board material itself. If you don't remove the paint, does the paint transmit strain properly? We don't know that. How good a paint is this? It's on a ruler. I'll say no more. All right, now that we've finished our wet abrade with the 400 grit, we're now going to scrub with the conditioner A, a final scrub to remove any loose material and do the final removal of the oxidization on that copper surface. He's going to use a cotton tip applicator, a CSP1, and he's scrubbing it across there just to make sure he gets most of the material, the loose material, into suspension. And then with another clean, dry gauze sponge, he's going to fold that into quarters and with a single wiping motion absorb the material off the circuit board. And then the last step of surface preparation will be the neutralizer 5A, the blue tip bottle. And this is going to bring the surface pH to nominally neutral or slightly basic. And the M-Bond 200, the adhesive we're going to be using, does not like an acidic surface. In fact, if conditioner A were your last step, I can almost guarantee a problem. You're not going to get it bonded. So scrub with the conditioner A, and then a single wipe with the clean, dry gauze sponge to absorb the excess material. And let's just make this look a little cleaner here. Throw away the surface. So now we need to lay the gauge out on this glass plate. First thing we want to do on the glass plate is do a little maintenance work. We'll take some neutralizer 5A and a gauze sponge, and we'll clean that surface. A couple of drops of the neutralizer 5A. I'm using a glass plate because it's easy to clean and it's also easy to tell if it's dirty. And you don't want to lay your strain gauge out onto a dirty surface to contaminate it right before you put it on the part you're going to gauge. So the next step is to remove the gauge from its acetate folder. I just slide it straight out. There you go. And now we're going to take the PCT 2M tape, and I'm going to take a piece off here and throw it away because it's been contaminated. I'll pull out a piece. I'm going to stretch it so it doesn't curl up so much, and I'll put two little handles on either end. Oops, it's curling up. Make a liar out of me. And then because of the small nature of this gauge, we're going to just run it transverse to the long axis of the material there. Now it's really important that when we lift up this tape, we lift it at a shallow angle. If I pulled it straight up, we would probably damage that gauge by bending it. Once I get past the gauge, it's not so imperative to worry about bending it. Now I'm going to lay it out on the surface, right in the center of that surface prepared area. We would have made alignment marks to make it specific, because if we were making a stress analysis application, it would be a specific location. And at this point, we basically want to expose the bonding surface of the gauge. We'll again lift at a shallow angle until we're past the gauge. We'll flip it back on itself. In this particular case, I'm going to avoid using the catalyst C because of an issue we've observed on this particular material. The catalyst C doesn't do well. So I'm going to take a single drop of the M-Bond 200. Not quite enough. I'm going to pull the tape over, and then Hugo's going to squeegee through with his gauze sponge folded into quarters, and then follow with his thumb. And he's going to hold that on there for 1 full 60-second minute. Don't trust your head, trust your watch. Your head's in a hurry. Also, when finished with the M-Bond 200, always cap it in between, because it absorbs moisture and that will kill it. We've now reached the 1 minute mark of thumb pressure, and we'll go ahead and take his thumb off. And then we'll leave it for 2 minutes under the tape. This allows the cure of the adhesive to fully cure before we try and remove the gauge handling tape. Okay, we've finished our 2 minutes of time underneath the tape, and now Hugo's going to pull the tape 180 degrees back on itself, putting it into shear as opposed to peel. Our adhesives are not terribly good in peel, but they're excellent in shear, and it appears that we've got a well-bonded gauge. Doesn't look like there's any voids or discontinuous behavior. So small, it's kind of hard. We'd almost have to look at it under a microscope to look for uniform color underneath the grid, but I'm fairly confident that this gauge is properly bonded. Now, before we go too much further, because of the fragile nature of lead wires being pre-attached, we're going to go ahead and flip this puppy over and apply a strain relief, so that if we happen to tug on the lead wires inadvertently, we're not going to damage the strain gauge. So I'm just basically going to wrap it around the backside and tape it down, and voila. Now, for a quick and dirty test, we might not even put any environmental protection on here. If we were just going to bend it and see what happened, put it into a fixture or something like that. But because we're going to wait, we'll need to put our M-Coat A. It's a polyurethane material, single part, and it's air drying. Basically just flood the surface in and around the gauge, mopping it around, getting it up underneath the lead wires and making sure it's well sealed. Remember, this is an environmental protection. It's not a show car finish on a car, okay? Paint is not important. If it looks good, that's a secondary. The important thing is that it protect the strain gauge from the environment. Nice job, Hugo.
Thanks.
And all the materials we've used here today, Tom, are available at Digi-Key.
Very good.
The coatings, the adhesive, surface prep, the gauges, wires, everything you need to do strain measurements, including instrumentation.
If a large company has an account with Digi-Key, they don't have to set up an account. They just go in there, they order it, and it's quick and dirty.
Yes, nice. And you get access to Digi-Key's easy online 24 hours a day.
For the United States or the North America?
Worldwide.
Worldwide, really?
They ship worldwide.
Oh, okay. Even something else I didn't know. Okay. So Hugo, we bonded this 3-element rosette. It's a brand new C5K S5198. It's a brand new 3-element rosette from Advanced Sensors for use on circuit boards. And since Digi-Key is one of our distributors, we decided we'd put it on their ruler that came from one of the sensors show. And if you look here, we've got it hooked up. It's a 350 ohm, and look how small that gauge is, 350 ohms. Unheard of technology for today. We got it hooked up to the P3, and we balanced it out, and it's moved off about 2 counts, which among friends is still 0.
Yeah.
But if you look at it, when I pick it up, look, it changes a little bit. And when I twist it, it changes a lot more. Twist it the other direction, look at bending. And what this 3-element rosette is doing for me is it's giving me the ability to look at both direction and magnitude of the strains that would be going on. Even though they might be changing in direction, the 3-element rosette automatically calculates for that. The only issue with that is that you must sample your data simultaneously. Grid 1, 2, and 3 have to be sampled at the same time for the data to make sense.
And independently, right?
And independent of one another in a quarter bridge configuration. That's correct.